Hello, good morning, and today we will be taking up the topic of whole numbers, that is chapter number 2 in your CBSE book. So the learning objective for the day is differentiate between the whole numbers and natural numbers, and we will explain the closure property of addition and multiplication. So before we start, let us take the concept of the natural numbers. So what are the natural numbers? The natural numbers are also known as the counting numbers. That is 1, 2, 3, 4 and so on. These are known as the natural numbers. Now what are whole numbers? The natural numbers including 0 forms the set of whole numbers. So the natural numbers along with 0 form the collection of whole numbers, and in the number line you can show it like this. So starting from 1, 2, 3, 4 and so on are the natural numbers, and if you add 0 to the number line, then 0, 1, 2, 3, 4 and so on will give you the whole numbers. Coming on to the properties of whole numbers. First is the closure property of addition. It says when two whole numbers are added, the sum is also a whole number. So let the two numbers be a and b and the sum be equal to c. When you add a and b, that sum you get is equal to c. So then it says c is also a whole number. It means that the whole numbers are closed under addition. Now what is meant by closed here is that the number c also lies in the set of the whole numbers. Now let us understand this by an example. We know the whole numbers are 0, 1, 2 and so on. So when we say about a plus b equal to c, let a be 2 and b be 3. So the sum of these two numbers will be 5. Now this 5 is also in the set. That means 1, 2, 3, 4, 5. This is also under the set of whole numbers. Therefore, the addition of the whole numbers is closed. Hope you have understood. So now moving on to the closure property of multiplication. Just similarly like the addition, under the multiplication also the whole numbers are closed. So when you multiply two whole numbers, the product is also a whole numbers. That means if a and b are the whole numbers, then c, the product of a and b, is also a whole numbers. Thus, whole numbers are closed under multiplication. Like here you can take a as 2 and b as 3. So multiply 2 into 3. This will give you 6. Now this 6 is also a whole number. Thus the whole numbers are closed under the multiplication. Now let us check whether the whole numbers are closed under subtraction and division. The first example says 35 minus 15. When you subtract 15 from 35, you get your answer as 20. So 20 is also a whole number. So here you can see that on subtracting 15 from 35, we get 20 as the answer. But what if we do the opposite? That means we are subtracting 35 from 15. The difference will be the same but with a negative sign or a minus sign. So this is a negative number and negative numbers are not included in the whole numbers. Therefore, we can say that subtraction is not closed under whole numbers. Similarly, if we go on to example number 3, dividing 32 by 4. 4 8 times gives you 32. So your answer here will be 8. But in the fourth sum, if we check 4 upon 32, that means answer will be 1 by 8. Now this is a fractional form. This is again not a whole number. Thus subtraction and division, whole numbers are not closed under these two operations. So now under all the four fundamental operations, that is addition, subtraction, multiplication and division, we will check with the closure property of the whole numbers. Thus whole numbers are closed under addition and multiplication, and they are not closed under subtraction and division. We have already understood this by the examples. Now moving on to some questions. So first question says dash is the smallest whole number. We know that the whole numbers start from 0, 1, 2, 3, 4 and so on. Thus we can see that 0 is the smallest whole number. Next question, question number 2, it says are all whole numbers natural numbers? Say yes or no. We know that the natural numbers are the counting numbers. That means they start from 1. So 1, 2, 3 onwards they are the natural numbers. Only 0 is the one number that does not belong to natural numbers. So all whole numbers are not natural numbers. So your answer will be no. Third one says the difference of two whole numbers is always a whole number. Say true or false. We know, we have already seen that the whole numbers are not closed under subtraction. Okay. So if I subtract 3 and 5 or 5 from 3, we get the answer as -2. That is a negative number. So that is not a whole number. Therefore, the difference of two whole numbers is not always a whole number. It is false here. Question number 4. Which is the largest whole number? Since whole numbers tends to infinity, so we do not know the largest whole number. Question number 5. Which of the following natural number does not have a predecessor? We know that the predecessor of 2. What does this predecessor means? It means the number that comes before the given number. So if the given number is 2, the predecessor is 1. That is also a natural number. Similarly for 3, the predecessor will be 2. That is also a natural number. For 1000, the predecessor will be 999. That is also a natural number. But for the D part, that is 1, the predecessor is 0 and 0 is not a natural number. So, the D part is the correct answer. Question number 6. Are the whole numbers closed under subtraction? We have already seen that the whole numbers are not closed under subtraction. So your answer will be no. In the 7th question, are the whole numbers closed under multiplication? Yes. Whole numbers are closed under multiplication. Let us check the answers in the next slide. Here they have given some more questions. Smallest natural number is, we know the natural number starts from 1, so the answer is 1. Smallest whole number, we already know it is 0. The whole numbers which is not a natural number is 0. Whole numbers are closed under addition and multiplication, and whole numbers are not closed under subtraction and division. Hope till here it is clear to you. So now moving on to the next learning objective, that is to define the commutative property for 4 operations. The commutative property is also known as the order property, and the 4 operations are the plus, minus, multiplication and division. So solve problems based on the commutative property. So we will be learning about the commutative property and we will solve some problems related to the commutative property. So here try to add 56 and 40 and get the answer. So 56 plus 40 gives you 96. Similarly add 40 and 56. You will get the similar answer. So what can you say about both the sums? Both the sums are same. So if we change the order of addends, that means We are changing the order of addends, means we are bringing 40 in front and we are taking 56 to the back side. The sum does not change. That means 56 plus 40 will be equal to 40 plus 56 and both are equal to 96. So changing the order is not affecting the sum. From this we can clearly understand about the commutative property of whole numbers. So an operation that means either addition, subtraction, multiplication or division. It is said to be commutative if you can change the order without affecting the result. So if A and B are any two whole numbers, then A plus B will be equal to B plus A. We have just seen. Thus the addition of whole number is commutative. Similarly, if you multiply two whole numbers, that means A into B will be equal to B into A. Just take an example, multiply 2 into 3 and 3 into 2. The answer for both of them will be equal to 6. So there is no change in the result. Thus multiplication of whole number is also commutative. Next comes the additive property of 0. Additive property of 0 means if you add 0 to a number, any whole number, you get the number itself. So if A is any whole number, then A plus 0 will be equal to 0 plus A. Since it is commutative, the addition is commutative in whole numbers and the answer will be equal to A. You add 0 to A, you will get the number itself. Hence 0 is called the additive identity. The identity of the number is not lost. Thus 0 is known as the additive identity. Similarly, like the additive property of 0, we have the multiplicative property of 1. You multiply 1 by any whole number, A into 1 or 1 into A. You get the number itself. The result is A only. Thus, 1 is called the multiplicative identity. That means the identity of the number is not being lost. Thus, 1 is the multiplicative identity. Multiply any number by 1, you get the number itself. Here we will be checking about the commutative property under all the fundamental operations. So we have already done that addition and multiplication are commutative, while subtraction and division, they are not commutative. So 2 minus 3 gives you minus 1. 3 minus 2 gives you 1. The subtraction is not commutative. Similarly, 32 divided by 4 gives you 8, while 4 divided by 32 will give you 1 upon 8. Thus, we have seen that the commutative property holds good for addition and multiplication. So let us solve some question based on the given topic, that is 234 plus what number will be 145 plus 234. This is commutative property of addition. So in the blank the number will be 145. This is A plus B will be equal to B plus A. Second question says dash is called the additive identity for whole numbers. We have just seen that on adding 0 to any whole number we get the number itself. Thus 0 is the additive identity for the whole numbers. Third one, what number into 1 will give me number 95? So 95 is the number 1 and this is the multiplicative property. So on multiplying 95 by 1 we will get the number itself. Question number 4. 45 plus what number will be equal to 45? Similarly, this is the additive property. So on adding 0 to 45, you will get the number as 45. Question number 5. It says 5 into 8 is equal to dash into 5. This is the commutative property of multiplication. That means A into B is equal to B into A. So here it will be 8 into 5. Question number 6 says, we know that 0 into 0 equal to 0. Is there any other whole number such that A into A equal to A? So, let us try with 1. 1 into 1 will give me 1 itself. So, thus the other number then 0 is 1. But if you take for 2, 2 into 2 will give you 4, and this will not be true for whole numbers above than 2, above than 1, sorry. So state the property used. In the second part, we have to state the property used. The first one says 19 plus 0 equal to 0 plus 19 equal to 90. This is the additive property, where you will be adding 0 to the number and you are getting the number itself. B is C into D is equal to D into C. This is the commutative property of multiplication. And in the third one, we are multiplying the number by 1. That will give the number itself. So this is the multiplicative property. Hope this is clear to you. So let us check the answers. So here are the answers for you. You can check. You can take a pause and check the answers. Here is an assignment for you to solve, that you can pause and solve the assignment, and the answers are given in the next slide. Here are the answers for the first assignment, and then we will be moving on to some more questions based on the commutative property and the closure property. So here are some more questions on the commutative property. The first one says 36 plus 64 is equal to 64 plus 36. 9 into 8 is equal to 8 into 9. This was the commutative property of addition, and this is the commutative property of multiplication. The additive identity for whole number is 0. The multiplicative identity for whole number is 1. Identify the property. 567 plus 678 gives you 1245. So here you can see that when we are adding two whole numbers and getting the whole numbers, and we know that the whole numbers are closed under addition. So this is the closure property. What property it is? Closure property. Sixth one says commutative property is true for addition and multiplication. The answers are given to you on the next slide. So let us check the answers. So here are the answers for the previous slide, and that's all for today. So what we have learned today is the closure property and the commutative property of the whole numbers under the four fundamental operations, that is addition, subtraction, multiplication and division. Hope this is clear to you. Go through the slides again if there is any doubt. Okay, and you can comment on the video also. Thank you, take care, and we will be doing the associative property in the next video. Till then, take care. Bye bye.